Hi guys, hope everyone's well. So we're on lesson 2 today. Today we're going to be finding the cube root of perfect cubes. And we'll see how cubes and cube roots apply to volume. You have a do now that you could try before you watch me do it, and check your homework answers from the night before you move on to this lesson. Make sure you could do square roots first. So I will go over the do now and I'll do the development with you. After the lesson's over, you should be able to find the cube root of a number, and you should know what it means to be a perfect cube. Remember yesterday we talked about perfect squares, and your homework is the problem set. So let's move on. So we're on cube roots, and it's asking us to find the volume of these cubes. Volume of a rectangular prism is length times width times height. So it's a cube. I'm going to find the volume by doing 2 times 2 times 2. 2 times 2 is 4. 4 times 2 is 8. The volume of this is 8 cubic units. Or we could write units cubed. The volume of B is 4 times 4 times 4. 4 times 4 is 16 times another 4 is 64. So this is reminding me of our exponent unit. Right here I'm doing 4 to the third power. I do get 64 cubic units. And this last volume is 10 times 10 times 10. I'm really doing 10 to the third power. So the volume is 1,000 cubic units. So Chloe wants to build a storage container in the shape of a cube. That holds 125 cubic meters of hay. So I'm filling this. Remember, filling a three-dimensional figure is volume. So they're telling me that the volume is 125. I'm trying to think what times what times what. What to the third power is 125? What do you think it is? I bet you're right. If I do 5 times 5 times 5, I get 125. So those of you who said that x must be 5, you're right. It's 5 meters. And what I just did, and you didn't even realize it, was I took the cube root of 125. So like yesterday, square root was the opposite of squaring. Cube root is the opposite of cubing. So as long as you know how to cube, you know how to cube root. So part 3 of our do now, we have to fill in the tables. Some have been done for us, just like yesterday's. 1 times 1 times 1 is 1. 3 times 3 times 3. 3 times 3 is 9. 9 times 3 is 27. 5 to the third power is 125. 6 to the third power. 6 times 6 times 6 is 216. 7 to the third power is 343. 8 to the third power, 512. 9 to the third power is 729. Now, something you're going to notice between yesterday's lesson and today's lesson is that cubing positive numbers give you a positive answer, and cubing negative numbers gives you a negative answer. Remember, we didn't get any negative answers yesterday because we were only squaring. Now we have 3 negatives. Negative 1 times negative 1 times negative 1. Negative times negative is positive, times another negative gives me a negative answer. So now I can take like a cube root of a negative number. I don't have to type anything in my calculator. If I know 3 to the third power is 27, then I know negative 3 to the third power is negative 27. So this list just turns out to be negative. So if you want to remember a list of perfect squares, you only have to remember like the positive list, and you know that the negatives exist. And we will refer back to this list of perfect cubes to help us with the lesson. So cube root is the inverse of cubing. Remember, inverse means opposite. Every number, positive, negative, or 0, has just one cube root. Square roots, there are 2 answers. Cube roots is only 1. Numbers whose cube roots are integers or quotients of integers are called perfect cubes, and we talked about the perfect. Remember what a square root looks like. To make it a cube root, you just put a little 3 in the corner. So if I want to find the cube root of 1, it's the opposite, and I get 1. 1 times 1 times 1 is 1. The cube root of 8, what number times itself 3 times is 8? It is a 2. The cube root of 27 is 3. And we really can just refer back to this list, right? The cube root of 64 is 4. The cube root of 125 is 5. And so on. And I can take the cube root of negative numbers. So we saw yesterday on our calculator we got an error message if we did square root of a negative number. Let me just remind you. If I do the square root of negative 1, my calculator says non-real answer. I get an error. But if I do the cube root, now my cube root is in this math button. If I do the cube root of negative 1, I'm not going to get an error message. I get negative 1. And that's because of this list over here. That negative 1 to the third power gives me a negative 1. Right? Negative 2 to the third power gives me a negative 8. So I know that the cube root of negative 8 is negative 2. And this whole list will contain negative answers. So just like what I've been saying, we notice now that we can take the cube root of a negative number. We couldn't take the square root of a negative number. So we can look at it in equation form. What number to the third power is 8? X would be 2. And there's only one answer. It's not negative 2 also, because negative 2 to the third power would give me a negative 8. What number to the third power is negative 125? Oh, I guess X would have to be a negative 5. Let's do some examples. Cube root of 729. I actually don't have them all memorized, so I refer back to my list all the time. It's 9. I remember this one. Tens aren't so bad. 10 to the third power is what gives me 1,000. And the cube root of 512, that's 8. What number to the third power is 216? That's 6. Remember, just like with square roots, I can separate the numerator and denominator. I could write this as the cube root of 8 over the cube root of 64. Cube root of 8 is 2. Cube root of 64 is 4. I can simplify this to be a half. The cube root of 0.125, well, let's look at 125. The cube root of 125 is 5. So this will be a 0.5. And again, you could always use your calculator to test things out. I could do 0.5 times 0.5 times 0.5. And I see I get 0.125. Or I could do the cube root of 0.125, and I see that I do get 0.5 as my answer. A number to the third power, that equals -8. I remember that as -2. A number to the third power, that's -125. That would be -5. The cube root of -729 would be -9. And the cube root of -512 would be -8. Again, it can be related to volume. So if they tell me that the volume is 216 of a cube, the length of one of its sides, it really means I'm trying to find the cube root of 216. Or what I can say is I'm trying to think of some number to the third power that is 216. This is probably the nicer way of writing it. So a number to the third power that's 216 would be 6. So what is the length of one of its sides? It would be 6 centimeters. The radius of a spherical globe. Okay, so a sphere, they gave me the formula right here. I'm going to use that formula and substitute in the information I know. They're telling me what the volume is. So in place of V, I'll put 288 pi. Now they gave me an exact answer, right? When the pi is in the answer to a volume question, they gave you an exact answer, which is actually easier to solve this equation, because watch what's going to happen. I'm trying to find the radius. How about the first thing we do? So I actually feel like dividing both sides by pi first. Remember, I'm trying to solve for r, so I'm trying to get it by itself. So if I divide by pi here, it's gone. And if I divide by pi here, it's gone. So that's why it's nice to have an exact answer, because now I just have 288 equals 4/3 r cubed. Now, if you remember, when you have a fractional coefficient, you should multiply, maybe not should, but a very good method, the method I prefer, is to multiply both sides by the reciprocal. Remember, whatever you do to one side, you have to do to the other. The reciprocal works because this 3 and this 3 is simplified to be 1 over 1. The 4's simplify to be 1 over 1. And I'm left with r to the third power on the right side. On the left side, you could even just use your calculator and do 3 times 288 and then divide by 4. And you get 216. And now I want to think about what number to the third power is 216. Just go look at your list. 6. The cube root of 216 is 6. So the radius is 6. 6 what? 6 inches. Find the volume of a cube. If the side length is 4, that's easy. Volume would be length times width times height. 4 to the third power is 64, and this is in cubic feet. Number 14, Dylan has a planter in the shape of a cube that holds 8 cubic feet of potting soil, so it's filled. which means the volume was given to us. If volume equals length times width times height, and if it's a cube, the length and the width and the height are all the same thing. So 8 equals x times x times x, or 8 equals x to the third power. What number to the third power is 8? Oh, x would have to be 2. 2 what? 2 feet. The side of the container is 2 feet. And then you have your problem set. So good luck. Talk to you soon.